so little faith. Truly I tell you, if you have faith as small as a mustard seed, you can say to this mountain, move from here to there, and it will move. Nothing will be impossible for you.
I can feel a change in the wind. I can change your heart if you let me in. Do you believe we'll do incredible things? Soar above with incredible wings. All I need is all that you can give. Faith in the smallest amount. Giving me your power where it counts. I can make your greatest wish come true if you believe.
Hello, good morning slash afternoon. Ryan, how are you doing today, my friend? I hope you're doing absolutely fantastic. Let's go to the big screen here. Let's take a look at my face. There's my face. It's a face. It does things. I don't know what to tell you.
What's in your heart?
Hello, Chelsea. How you doing?
Let you try, that's when we can start.
How you doing? Good morning slash afternoon, Steven. Hello. Good morning. How we doing this absolutely gorgeous day? Hopefully we're doing fantastic. Good to see you. Good to see everybody. Bernice, hello. How we doing? How we doing today? Good morning, guest slash afternoon, of course. That's the important part. Yes. Everybody doing good today? Hopefully you're all doing very well here today. Having a Hey Josie, hello. How we doing? I think it's been a pretty productive day so far. I ain't gonna lie. Yeah, everybody's been doing. Make some grilled cheese. Ooh, ooh, ooh. I'm I'm already jealous. It took all of 3 seconds. You said grilled cheese, and I'm like, it does sound pretty good. I ain't gonna lie. I think I'm gonna get a sandwich this afternoon for lunch. But trying to be a little bit healthier, just a little bit. I know I'm really out of shape. I ain't gonna lie, but trying for a little bit of a healthier alternative. JJ sounds really good. I ain't gonna lie. I think JJ sounds pretty good. Or maybe a sandwich and a salad. If I go with that, that's a pretty solid combination. I know JJ's don't do salads, so they do their reduced fat sandwiches instead. It's like less bread. There's no bread, but you know, they got the other thing there. Um, the lettuce around it or something like lettuce wrap. Yeah. It sounded so awkward, but it's true. It's true. What are you guys doing here today? I gotta know. The Unwitch, yeah, that's what it is. The Unwitch. Yeah, see, look, you guys know more than I do apparently. Apparently, no, definitely, yes, that's 100% true. I was trying to think of the name. I'm like, there's a name to it on the menu. I totally forgot though, bro. You know how it goes. All right. We got a little bit on the agenda here today, but not too much. By the way, everybody, for just a little bit of an early view here, who came literally, I'll probably announce this again anyway. If you did see on the on my math lab here yesterday, I did put up the test there in the practice test, so it is there, ready to get started at your leisure there. I basically took I had a pool of 125 questions, and I managed to pare down 85 questions. So there's only 40 questions on this exam. So I took 85 questions off. I was like, man, that's so good. So I was like, that's a really good healthy healthy chunk that I took out. So I think it's a much more manageable thing. Like 125 down to 40. I think I can work with that. I think you can work with that too, in all honesty. So, hey Jess, hello. Good morning / afternoon. Nicholas, hello. Good morning / afternoon. Hopefully doing absolutely fantastic. Absolutely fantastic. Everybody's doing really good. I don't know, I'm getting good vibes again today. I'm feeling good vibes. That's what I'm feeling. I'm doing, yes, absolutely, my man. Absolutely, Nicholas. 100%, my friend. 100%. Gonna take care of this little good dude here. Yeah, we'll go. Hopefully that goes. All right. No? Guess no. Pretty nice. Please. No, you just don't want to do it. You suck. All right, hang on a second, folks. Tell me, what's the story here? Any plans? We're almost at the end of the second week here. What's the drink of the day? Ooh. I'm so glad you asked. What is the drink of the day? This is a very good question. I approve of this question. There we go. Sorry about that. I had to take care of something. All right. Now I took care of it. Good stuff. All right. All right. So today's drink of the day is a very brand new drink of the day to the stream. All right. From all the streams that I've done, this is a brand new drink. A lot of the drinks that I do usually repeats, but this one here, since I'm going the healthy route here. All right. Lysa Rena, hello. Good morning / afternoon. Danny, hello. Good morning / afternoon. Hope you're both doing absolutely fantastic. We're talking about the drink of the day here. The drink of the day here today, ladies and gentlemen, brand new to the stream here, is going to be raw kombucha. All right, that is the drink of the day here. I'm going the slightly healthier route here. We're gonna try raw kombucha here, and see if it provides said healthy benefit. That is the plan. Okay, so I had a sip already. It was pretty good. This is guava flavor. All right. Now it does say here on the back. Let me be a little clear here. It does have a little note here on the back of the thing. Yum Kombucha brand is pretty good. All right, I got this from Jules, the GT's Synergy Raw Kombucha. Now it does say in a little note here on the back. It says kombucha is a fermented tea that has naturally occurring alcohol. Do not consume if you are avoiding alcohol due to allergies and pregnancy and sensitivities and religious beliefs or whatever. So okay, so all right, so as again, it does have some bacteria in it, but it's supposed to be healthy bacteria for you. So there you go. So thank you for the hydrate there, Jess. Looks like we're having a thirsty. Thirsty. I was like, woo. Healthy booze. Yes, I guess so. I think it's probably trace alcohol because it probably just produces alcohol unnatural, these particular bacteria. I mean, cranberry flavor is best in your opinion. I'd take your word for that. You know, there's a lot of different flavors, I'm sure. I tried the guava because I'm like, oh, guava sounds pretty decent. So I'm like, you know, the guava's pretty decent. So I'm like, okay, that ain't too bad. That ain't too bad. This here. You're drinking right now. Respect. Respect. Let me tell this person. Here. Got a lot of work, just like so many people. Go. Lot of work I got to do here today. So, okay. The cranberry, drinking it. There you go. Tried kombucha, you didn't like it. You know, that's fine. You know, it's a acquired taste maybe. I don't know, but it's not really. You know, honestly, sometimes some drinks are not about necessarily. Excuse me. Some drinks are not necessarily about the flavor. Sometimes they're about the healthy properties behind it. So, like, take green tea, right? The green tea that I like is unsweetened. You know, you don't have to have sweet green tea. I love milk tea, by the way. You know, mind you, that you have the sugar and the milk in there, of course. That's really good. But I like unsweetened green tea too, and that has a lot of good healthy properties associated with it, such as, you know, antioxidants and whatnot. So, I mean, the taste is one thing, but again, getting the benefits out of it, you know, if you outweigh the drink, and if they say the benefits out of it is going to be helpful on the long run, you know, you can compromise a little bit in your taste profile. Doesn't mean you've compromised completely, but you compromise a little bit. I'm pretty sure you could work with it if you really wanted to. If you don't, hey, that's your prerogative. Got no problem with that because everybody's got an opinion about that. But I say you got to try something. You got to be open-minded. That's the important part here. So I had a colleague profess that kombucha was great. She's like, this is amazing. I'm like, cool. All right. And had a friend who's like, you should try and be more healthy. I'm like, okay. Well, I kind of put two and two together. And I'm like, here we go. Let's give it a shot. They've been trying to get me to try it for ages. So I figure if I'm stuck at home, why not try it now? All right, we have a few things here. All right, ladies and gentlemen, we're gonna do some intros here. All right, there we go. Got that done. We gotta do some intros here. We gotta get going here. We got a lot of work we gotta do here today, but we're gonna talk about a few things here. All right, let's do it here. All right, let's do some intros. Let's get going here. Okay, let's get started today. Welcome back to Wednesday. All right, so we're going to pick up where we left off last time. Last time we finished off Chapter 2 talking about inverse functions here. Okay, now today what we're going to be doing here is we are going to switch gears here, talking more about functions here, but more specialty type of functions. We're going to now expand functions here, looking at specific properties. So we're going to get more deep in depth regarding functions in general, and looking at specific types. Okay, so we're going to do section 3.1 here today for sure, and we'll get a little bit of section 3.2. Hopefully we get started with that as well. I do want to introduce a few questions here from section 3.2, so that'll be important for what we're going to be doing here tomorrow anyway. So at least I want to get it at least introduced, and then we can expand upon it tomorrow, looking at it in greater detail. Now, having said that, in any case, again, as a friendly reminder here, for those of you who came in here a little bit after 12 or a little bit late, or we're here just slightly before class, we had to go through the ads, but that's not a me thing, by the way. The ads are kind of like Twitch thing. Anyway, the test has been made up. The test has been posted. There's the practice test has been put up there, and also the test has been put up there. So I took 125 questions. I narrowed it down to 40. and it is up and ready for you to go ahead and give a try over chapters 1 and 2. So the time limit there is 600 minutes. You get, I think I put 5 attempts there for the exam. And again, do last day of class there. But again, highly suggested to go ahead and get that done. But probably a couple suggestions here. First, try and finish the homework here for chapters 1 and 2. That'll give you a good idea about what everything on the test here. But since you'll to double check, you can do the practice test here first. Practice test is the same exact 40 questions, just not the same numbers, of course. You can practice with that all you like. I put all the available materials there for the practice test to be available. So like view an example, help me solve this and stuff. You won't have that for the actual exam, but you will have that for the practice exam at least. And you can go ahead and give those a try and kind of work through it. You said we can leave the test and come back. Yes. So there's a save for later option there, Brian. So it's like, okay, you get up to a certain point, you're like, yeah, I'm kind of burned out. I'm just kind of burned out and doing questions. And then you're like, okay. So you can hit the save button there and it'll save it. And then you can come back the next day. You can log in and it'll start from where you left off. The only thing is that you can't do the questions that you tried before. So again, you can't go backwards here. You have to go kind of in order. So once you cut it off and save it, you're like, okay, you're going to start from that question. You can't go back. All right. So again, please keep that in mind. All right. So that's kind of like how the system works there. So, but there is a save for later option just in case if you don't want to do 40 questions all at once, which is understandable. So, not making this like you have to do it all at once, like though. Are the questions in orders by section? Yeah, basically that's all I did. Is I have questions from I put them in order like from 1-1-1-5 and then 2-1 to 2-2-7. So yeah, they're pretty much in order, I guess. Yeah. They're not randomized or anything. They're just there. I really didn't yeah. Like you'll see what you see on the practice test there, Bernice, is exactly how the questions are going to come out for the actual test. So, like the mock test there is the practice test, and then the real test is going to look pretty similar, just with different numbers. That's pretty much it. So, if you try the practice test, people who did the practice test, by the way, did a lot better on the exams for people who didn't try it. So I'm just going to point that out there. If you think you can skip by it and you're like, oh, I'm just going to get everything, like, it doesn't really work out that well. So definitely try the practice test. And if you do try the practice test here, there may be bonus points heading your direction. So, think about it. Just think about it. Maybe you get some bonus points because you decided to take a little bit of extra time and decided to do some work. Respect. Respect, everybody. It's always good. Okay. All right, so today, let's go to the big board here for today. Go to the big board. Bam. All right. Anybody have any other questions before I move forward? Any other questions before we... All right. All right. Let's go ahead and do this here. Easy cells. All right. So today we're going to go to section 3.1 here. Today we're going to be talking about quadratic functions. Okay, so we're going to talk about quadratic functions here. Now, we talked about quadratic equations already in the very first section in chapter 1. Now we're looking at quadratic functions here, which is pretty much the same thing, but we're going to be looking at this more in depth here compared to what we did in the very first section there. Okay, so what is the general form of a quadratic function? All right, so the general form of a quadratic function is stuff that you've seen before. That's equal to f of x, which is equal to ax squared plus, that should say bx, not b, sorry. Let me change that over. How we can change this. Sorry about that. That should say bx, not just b. There we are. So, all right. So ax squared plus bx plus c, where a, b, and c are any numbers. So here we have 2x squared minus 10x plus 3, and again, minus 4x squared minus 6x minus 123, whatever. They could be whatever numbers you want. Those are some general forms of quadratic functions. Simple enough, things that you've seen before many, many times. All right, now, what we're going to be doing here is we're going to be transforming some of these general form of quadratic functions, and we'll be changing it into a standard form of a quadratic function. So we have a general form and we have a standard form. Now, as you take a look here, number 2 says, what is the standard form of a quadratic function? So the standard form here is f of x is equal to a times x minus h quantity squared plus k. And this h comma k here is going to be the vertex of the quadratic function here. Now, if you remember here, actually, I'll put this as a note here, probably important here. But remember what is the vertex here? The vertex here specifically is the point on the parabola on the very top or very bottom. Okay, so it is basically either at the top of the parabola if it's opening up, if it looks like a hill, or if it looks like a bowl, it's at the very bottom of that bowl. It's that particular specific point. Okay, that is what the vertex is going to be. Okay, now I also put a secondary note here, and I said, okay, remember that the x value of the vertex here is opposite of what is written. Now, why is this the case here? The reason why this is the case is because, take a look here at the standard form one more time. It says x minus h quantity squared. So whatever is put in there, you just put in the opposite number here. So if this says x minus 5, for example, then really the x-coordinate of the vertex here is actually positive 5 and not negative 5. So it's a pretty common mistake to kind of miss that part there. So again, please be very careful about that. That's why I went ahead and put up a note here just to kind of highlight that, because it's the most common mistake I see on the on problems when you have to work with it. Okay, so all right, we're talking about letters here. Great, all right? Letters make things more confusing. Totally get it, all right? But let's say we want to move away from letters and let's work with actual numbers. All right, so the actual number side here says, okay, let's look at number 3. Number 3 says, okay, how do we go from general form to standard form? So the general to standard form here is what we're going to get after. So I talk about the trick here, and we're going to look at an example here in just a second. The trick here is to use the concept that we talked about here back in chapter 1, and that was completing the square. In this case, though, if you take a look here carefully at this trick, we are completing the square on one side of the equation. So more importantly here, it is one side of the equation that we're actually going to be completing the square on. All right, so the process here is going to be pretty much the same, but it's all going to be on one side of the equation. All right, so I know that sounds really weird, but I think when we look at it on a practical level, it'll actually make a whole lot more sense. All right, so we'll need to go ahead and take a look here at a specific example here. And let's see exactly what we need to be working with. So let us look here for, yeah, why not? We'll start with that, and then we'll kind of work our way up. All right. Okay, so let me bring up the paint tool here. Oh, I did. That is. All right. All right. So let us go with an example here. We'll put down a quadratic function here to start with. Let's go with f of x, and we'll just start with something super simple. Okay, nice and easy to work with. So we'll go with x squared minus 2x minus 15. So here we have a general form of the equation, okay? So the general form here is x squared minus 2x minus 15, okay? So let's take a look on how we can go ahead and transform this into the standard form that we want here at the end of the day to get some information regarding this quadratic function. Now, what's the first step here? Well, if you remember here from completing the square, in step 1, we're just going to separate the x guys and we're going to separate them from the numbers, okay? So let's at least going to put this one at a time here, and I'll come back to this. I'll kind of go back and forth here. But step 1 here is just separate the x's, the x guys, I'll say the x guys, from the number on all right, to do that, it's fairly simple here. All you need to do here specifically for this particular problem is what you'll need to do here is go ahead and just you know, put some parentheses around the x guys here. Okay, remember one important thing: you're not allowed to go on both sides of the equation. You can only work on one side of the equation. That's it. All right, so there's restrictions in this particular process. All right, you can only work, like in this case here, I can only work on the right-hand side. That's it. So if you're thinking at any moment in time of adding 15 to both sides or doing anything like that, that is not possible in this process to get it to work. Okay. But we do have things to compensate for that, so we're going to cover that here. All right, so that's step 1. Step 2 is pretty much the same step 2 as before. All right, take b, divide it by 2, and square it. Okay, so that is nothing different going on here in this case. So if we take a look here in this instance, where we're going to take is that minus 2 here, that's our b. We're going to take minus 2, we'll divide that by 2, and we're just going to go ahead and square it, just like we have from before. So here we get negative 1 quantity squared, and here we get positive 1. Okay, so nothing too crazy going on here. Nothing too crazy going on here. Very simple and straightforward. It's exactly as we set it out from before. Okay. All right, so nothing changes, at least for step 2. So what's step 3? Step 3 is we are going to basically do something very similar here that we did here back when we did originally completing the square. We're going to add result of step 2 inside the parentheses with the x's, with the x guys here, and we're going to do one more thing here. Now, before I write that specific thing here, here's what I'm going to show you here, at least the first half. I'm going to add 1 in here. Okay, that's what I'm going to be doing here. I'm going to add 1 inside here, inside these parentheses. Okay. What should I do to balance this out? Remember, we're dealing with algebra here, so everything is a balance, right? So what should I do here? If I'm adding 1 here on the inside, what do I got to do here in order to balance out that plus 1 that I just randomly added? What do you think I have to do here in this case? What do you think? What do you think I need to do here in this instance? Add it to the minus 15. All of you say plus 1 to the outside of the minus 15 here, okay? Nicholas says minus 1 on the outside, okay? All right, so let's think about it this way. All right, so let's, one of these answers is correct, by the way. I will agree. One of the 2 answers here that we see here, it's either adding 1 or subtracting 1, all right? Totally agree. Now, here's the way it works, right? Here's the way it works. At the end of the day, right? At the end of the day, we added 1 here on the inside. Okay, we added 1 here on the inside. Now, in the old process, we added 1 here to the other side of the equation. But we now have the restriction of only working on one side of the equation. Essentially, if we're balancing stuff out, we got to play a zero-sum game here at the end of the day. So if I magically add one here on the inside, I have to, and Nicholas here is correct actually, we're going to actually subtract by 1 here on the outside. Okay, so you have to compensate by the opposite in this particular instance because you are working on only one side of the equation. Okay, you can't use both sides of the equation, so you need to only work on one side. So you're going to subtract here in this case by whatever that number is on the outside. So I will put a more generalized version here of this step. So meaning to say step 3, so you're going to add this step inside the parentheses and subtract by the appropriate amount on the outside. Okay. I say appropriate amount here because, of course, that can change based on a couple things, which we'll look at in another example. So, okay. So I do want to point that out here. All right. Step 4 is pretty easy after that. Step 4 is to go ahead and factor, and you have. Okay, so all right, so the last step here is factor, and you'll have the standard form, and it's pretty simple. But let's take a look here at this last part here. So here we have x squared. Let's take stock here. We got x squared minus 2x plus 1. And we have minus 16 here. Okay, so now all we have to do here is go ahead and factor x squared minus 2x plus 1. So that specifically is going to be x minus 1 quantity squared minus 16. And there you go. You got yourself a winner. That's how we can get it into our standard form. There any questions about that? Let me go back to the notes here so you can possibly copy that down. Went too fast with that. You go ahead and copy that. Just real quick, because this was last week, x minus 1 I got from dividing. So that's the final answer. You don't have to solve for x. Not in this case, Jess. Brian, real quick, the x minus 1 I got because it always factors to that. Remember, go back to your steps here, Brian. We have, again, negative 2 divided by 2. That's negative 2 squared. It will always go to x plus whatever this number is in the parentheses. That's how, again, completing the square. That is always the predictable pattern there for factoring. So it'll still follow the same thing for what we did last week as it does for this. Nothing changes in that regard. All right, cool. Now here's an extra question here. Can anybody tell me what's the vertex of this quadratic function? Anybody tell me what is the vertex of this quadratic function? What's like the tallest? What's the biggest point or smallest point here on this parabola here? What's the vertex here? That top of a hill, bottom of a bowl point. Just based on what you see here. It's a point. It's a point, Brian. So I need an x comma y here. I need a point here. Remember, a vertex is a point. So anytime I'll say a point here in class, I always want it in terms of x comma y. That's how it's going to go. So the reason why I'm a stickler about that is because that's again, you just like Let's just plop in one number. And I'm like, ah, no, please. All right. So 1 comma minus 16 is correct. So 1 here is the x value of the vertex. Again, let's go back here for just a second. This is x minus h plus k. So again, the h here is the opposite number here, which is opposite of 1, minus 1, which is 1, and then the number here on the outside, which is minus 16. Again, just making sure we cover our bases there. Brian, I'm not trying to be hard on you. I'm just making sure that, you know, you get to be consistent in that regard. Because there's a lot of questions that involve like, hey, what's the vertex of this guy? And then you got to answer that. And then if you just put in a number, it's just going to keep telling you you're wrong. So want to be sure you get your bases covered there. Okay, cool. Ooh, that was long. All right. Okay. I'm going to quickly do another problem here, and then we'll move forward. So this next problem here is pretty similar. I'm going to buy this one here a little bit quicker. Oh, yeah. Do that one? Sure. All right. We have 2x squared plus 4x minus 3. So let's say this is our function here. Okay, so there's only one real important trick to this problem here compared to the last example we did. Again, the same steps are going to apply. You're still going to put the x's here together. Okay, so all the x guys here go in a set of parentheses. That's fine. And minus 3 is going to go on the outside. Fine. All right, same as before. The only difference in this problem here is this very next step that we have to do here. That is, again, because of completing the square, we have to make sure that this number in front of x squared is going to be 1. All right, so what you'll need to do next here, and again, this will be a little weird word warning here. All right, in this case, we need to factor out a 2. Whatever number is in front of x squared, it doesn't matter what this number is, and no matter how ugly it's going to look after factoring it out, doesn't matter. You're going to factor that number. That's just how it is going to be if you're going to make this process work. So, yo, Yusuf, my dude, how you been? Hopefully you're doing good, my dude. It's going well. How have you been, man? Yusuf, I'm looking forward to trying to buy a kit, okay? That's the plan, all right? My plan is to buy a kit, all right? Once those Hummel kits go, I'm going to buy one, man. All right. So here I got 2 times x squared plus 2x minus 3. All right. Now I just proceed to go ahead and do the same thing as I did before. So again, I'm going to take that 2, I'll divide that by 2, and I'll square it. So here I get, of course, I get 1 squared, which is 1. So I'm going to do the same thing as I did before here. I'm going to add 1 because that's what I got here. Now, here's the question one more time. What do I put on the outside here? I added 1 here on the inside. What am I subtracting on the outside? Ooh, nice, Yusuf. Absolutely. You guys are pretty quick to judge. Like I said in this class, we never assume. Haha. But I think Steven got it here. That answer is indeed minus 2. That is correct. Minus 2 is correct. If you added 1 here, you actually have that 2 sitting on the outside. All right. Be careful about that. You have that extra 2 sitting out there. That's 2 times 1. You actually added 2 in that equation and not that 1. So you have to subtract by 2 to balance it out. So that's why I put the step there in the notes. It's like, that's why I put the specific step is the appropriate amount on the outside. So that's where you need to be very careful. Okay. Yes, that's a tricky one. Yes. There ain't a question about it. That's a tricky one. That's why I did this example here specifically for this part. Right? Not only to factor out that coefficient of x squared, that's what we got to do. Fine. But that's the real kicker for this problem here, is knowing what to subtract on the outside. Easy to add on the inside because it's like straightforward, but that last part there, very tough. The most common mistake I see on this particular type of version of the problem. All right. Now the rest of this goes exactly the way you think it does. There's no difference on how you're going to do this here. You're just going to factor this here. This is x plus 1 quantity squared. You get minus 5 here on the outside here. So this is your standard form of this particular equation. Right? And so what's our vertex here for this guy? What's our vertex here for this guy? Anybody tell me what's the vertex here for this dude? Why was it 2 and the last problem was 1? We have a -1 or 1 comma minus 5. Is it going to be 1 or -1? Oh, yeah, look at that. Yeah, them signs, let me tell you. So to answer your question there, E-Man, let me answer your question there. Yeah, -1 has got to be -1 comma minus 5. The reason why I'm adding, oh, sorry. Let me actually zoom out here because I'm seeing that step for you to see. The reason why here we subtracted 1 here on the outside, E-Man, is because we have a coefficient of 1 here on the outside here. So in fact, you just went ahead and you have 1 times 1 here. You added 1 here on the inside, you subtract by 1 on the outside. However, in this case, in the second case, you have this extra factor of 2. So when you actually added the 1 here on the inside, you actually added by 2 because you have 2 times 1 here. So you actually added 2 by actually multiplying these together. This actually turns out to be plus 2. So that's why we have the minus 2 here as a compensator to balance it out. So that's the key difference there between the first example and the second example, is that extra 2 you have here on the outside. That is a big deal. All right, a very big deal. Want to be sure, again, that's why that this little extra 2, this plays a humongous role. Humongous role here. Will that number always be 1? I mean, it's whatever b divided by 2 squared is going to be. That's what it's going to be. That's how it turned out for both of these problems, but no. Again, it's always, just follow the steps there, Brian. It's always going to be b divided by 2 quantity squared. So if this was different, if that was a 4 instead of, if that was a, like, 8, let's say 8. I'm talking about the red number here. You're talking about this 1 on the inside, on the outside. You're talking, again, it's whatever this is. Like, whatever this is, that's what you're going to put in right there. Doesn't matter what this number is. Guys, it's not always going to be 1. It's going to be whatever number you get for b divided by 2 quantity squared. So you follow the general steps here, but don't make the assumption that it's always going to be the same number every single time. That's a dangerous game you're going to be playing. How come it is, why is it -1 and not 1 for the vertex? Go back for a second. All right, one more time, everybody. Oops. Let's take a look at the notes here. What's this specific note I put here? Now, I put this note exactly for the question you're asking me. I would again, put that in italics, underline it, whatever you like. That is exactly why I put the note there. So remember, the x value of the vertex is always opposite of what is written. Always. So if it says x plus 1, it's actually -1 for your vertex, for your x value of your vertex. That is always the case, because that is exactly how standard form is written. Thank you for the hydrate, Joseph. You see, I gotta have my bases covered. This is exactly how I actually learned math, is just like taking it apart one piece at a time. And I started to give myself a little bit of friendly reminders like these. And I'm like, because math is about these nitpicky details. So it's like, well, let's put small notes just to give ourselves that very friendly push. There are a lot of rules, but well, the too many rules. You could say the same thing about the United States. There's just too many laws. We wish we could work without them, but you got to work with them. That's just how it rolls. Sadly. Gotta just know those nitpicky details. It's important. All right. Any other questions before I move forward? Uh, okay. Nope. Okay. All right. So the next set of questions here are kind of gonna all go together, okay? Because we're gonna break down a quadratic graph. Now, a quadratic graph is a parabola of some variety. Now, all of you have seen parabolas probably at some point, whatever the case may be. Doesn't matter if you've seen a parabola before. This isn't going to be like anything brand new that you haven't heard about already. But parabolas only are only going to look two ways. Okay, for us, for functions here specifically, um, parabola is going to be like goes like this or goes like this. Okay, in general, that's what parabolic functions are going to look like here. Don't say every parabola is going to look like this, but parabolic functions specifically will look like one of those two guys. Now, what we want to do here next is, let's go back to the handout here, is we're going to talk about number 4 here, and we're going to expand upon some of these subparts here. So it says, what information do we need in order to graph quadratic functions? So I put up a list here of some key pieces of information. We're going to go ahead and expand upon some of these here. So first and foremost here is which way the graph opens. Okay, so we're going to talk about that here in the next question. X and Y intercepts. Okay, so we've actually talked about X and Y intercepts already. Okay, so you can find x-intercepts if you factor or do the quadratic formula, or do the completing the square, that sort of stuff there. Y-intercept, very easy. You just plug in 0 for x, find out what you get for y. Very straightforward. We'll look at examples, of course, just a moment. Number 3, the vertex of the quadratic function. Okay, so we've already seen how we can transform it into a standard form, from a general to a standard form, and see what the vertex of that particular quadratic function is going to be. Okay, so we've already went ahead and seen that already. Number 4, we'll talk about axis of symmetry. We'll discuss that here fairly quickly. And then, of course, number 5 are some other points on the parabola. So, if you want a general shape of this parabola, you have you get a few more points to go ahead and plot on the graph and then connect the dots, and then you'll have a pretty good shape of the graph that you can go ahead and put together. So these are the 5 major things that we can have here specifically for quadratic functions that we want to go ahead and find. Now, let's break this down one piece at a time, and then once we break this down one piece at a time, we're going to go ahead and do an example here using each one of those pieces. Okay, so all right, so let's talk about the first one, which is which way the graph opens up. All right, so how do you know which way the graph opens? So if a is bigger than 0, then the graph opens up. Now, to clarify here just for a second, all right, because sometimes people get a little confused. And to be fair, that's a very fair statement. So what do I mean by a graph opening up? Okay, you're like saying, oh, okay, well, yeah, what does opening up mean? So if a is bigger than 0, oh man, that looks awful. All right, so if a is bigger than 0, the graph opens up. That means that the graph, in general, we don't know exactly what it looks like, but the graph is going to look like this. All right, the graph opens up like this. So the graph in general is going to look like this, okay? If a is less than 0, if a is negative, then the graph is going to open down, okay? So it's going to look like this. Okay, so opens up, it looks like a big old U. Opens down, it looks like a big old hill. Okay, there you go. All right, so if you have those in your notes there, then you know what opens up and opens down mean, at least in the context for what we want to be working with. So that's number 5. Now, this is just a simple observation here that we want to go ahead and use. Again, this a here, by the way, is the same a as the original function here of ax squared plus bx plus c. It's just that number in front of x squared. So that's the only number that you want to be looking at here in this case. Okay? So nothing too complicated going on there. All right, now let's also take a look here at another part that we'll be also looking at here in our next example, and that is talking about the axis of symmetry. Okay, so what is the axis of symmetry here? So the axis of symmetry here is, and I put a little bit base definition here, so let's go over that here very carefully. The axis of symmetry, or AOS, as I like to put it here, just for ease of use, is the imaginary line that cuts the parabola directly in half. So you take this imaginary line and you cut it directly in half, and that's going to be your axis of symmetry. All right. Now, what's interesting about this is, to make this as easy as possible, is that the axis of symmetry is always equal to the x value of the vertex. So if you find the vertex here fairly quick, and you find that, then you can find the axis of symmetry immediately after finding the vertex, because whatever that x value of the vertex is, that's your axis of symmetry. It's just that easy. And it should always be written as x is equal to the x value of the vertex. Yeah, pretty much. So if the x value of the vertex is 7, then your axis of symmetry is x is equal to 7. Yeah, that's it. Really simple. So not much going on there. All right. Any questions so far about that? Any questions? Okay, we want to be sure. Just want to take a little bit of a breather here. Just roll it back, because if I feel I'm going too fast, then I need to write stuff down. Go ahead and do so. We add in a few more notes after this, so. Let me know if you want me to scroll up again if you didn't see things. So, yeah, that's fine, Jess. Here's 4 and 5. That's fine. I write terrible, as you could tell on the paint tool there. That's probably how I really write. Even though I'm writing with a mouse, I pretty much write the same way. It's really awful. Okay. Hopefully we have that ready to go. Alrighty. I'm gonna move forward here. All right. Hopefully we got everything down. Yes. All right. Okay. So the next question here is going to be rather important. Okay. Okay, cool. Okay, so let's look at question 7. Now, question 7 says, what is the shortcut to getting the vertex of a quadratic function? So we saw one way to get the vertex is to changing it into standard form from a general form. But what's a shorter way to get the vertex here? Well, there is definitely a shortcut method here. So I basically broke it down into getting each coordinate here for the vertex. So we need the x value and the y value of the vertex. So to get the x value of the vertex, what we're going to do here is the x value of the vertex here is equal to negative b over 2a. Whatever b and a are in our original quadratic function, you just take negative b over 2a, and guess what? That's going to be your x value of your vertex. Once you have that, you have to find that first, because to find the y value here, you plug that value here into the original function to find your subsequent y value. So you are going to use your original function here. You're just going to take that x value, plop it in, find out what you get for your y value, and then put 2 and 2 together here. You got to put them together in a point, and there you go. You have your vertex. So you have a shortcut method here about which to go ahead and to find the vertex of any quadratic function. Again, this is only specified to quadratic functions. So, all right. All right. I do have this last question here. We'll just go ahead and state this here, which is pretty simple. What's the maximum and minimum for a quadratic function? Well, the maximum and minimum for a quadratic function is just wherever the vertex is located on that particular quadratic function. So if you find the vertex there, that'll always be your maximum, or that'll always be your minimum for your quadratic functions. So, because it'll always be, again, the top of the hill or bottom of the bowl, whatever the case may be, sort of deal. All right. Now, in reality, let's talk about what we've taught. I'm going to talk about what we discussed here the past 5 to 10 minutes. All of this is like, here's letters. I threw letters in your general direction. This is a lot of information. But you're like, wow, that's a lot to kind of digest. I'd be like, yeah, that's kind of true. It is a lot to digest. But how do I make this significantly easier? Let's at least answer that question. Because you know what? Yeah, or how do we make it, how do we, can we go back to, yes, you didn't get the equation? Sure, Joseph. So how do I make this more streamlined? Let's take a look at actual numbers here in this process about how I would go ahead and graph a quadratic function here using the information that we can get here one piece at a time. All right. So we're just going to get it one piece at a time, and then we're going to go ahead and put it together here all on one graph. Okay, so that is going to be our goal here for these next couple of examples for sure. So let's go ahead and do that right now. Bust out the paint tool. Just wipe the slate clean. All right. Okay. So I'm gonna go ahead and pick another thing here. Okay. Thickness is terrible. Okay, so I'm gonna go ahead and write a number down here, and we'll go ahead and do it out. No. Yes. All right. So here we have x squared plus 3x minus 10. All right. So let's go through every step here. And the way the steps are going to work, by the way, so I do want to point something out here. I did do this on purpose, by the way. Let's go back to number 4. Notice I put these in 1, 2, 3, 4, 5. I did this on purpose, by the way. I'm just going to point that out here. Because this is exactly how I'm going to go ahead and map out this particular quadratic function in terms of just graphing it. I'm just going to go step 1, just determine which way the graph opens. Step 2, find those x and y intercepts. Step 3, find that vertex. Step 4, the axis of symmetry. Step 5, any other points, and then just put it on a graph. That's all I'm going to do here specifically, is just go in this same exact order here that you see here on screen for number 4. So if you have these 5 things written down for number 4, this is exactly how I'm going to approach each single individual process in order to put this whole thing together. Okay, so let's go ahead and do step 1 here. All right, so step 1 here, we want to figure out if it opens up or down. Okay, so we need to identify what A is equal to. Can anybody tell me here, what is A equal to here in this particular equation? What's the coefficient or the number in front of x squared? What's that going to be? 1. Good. That is correct. Right? So if you want, you could go ahead and put a 1 here. That's perfectly fine. All right? And so if that's equal to 1, I agree. What does that mean? Does that mean that this graph here is going to open up, or is it going to open down? Will it open up, or will it open down? Okay. All right. Very good. That's right. You're going to open up, okay? All right, so we have the expectation here. We know what this graph is going to generically look like. It's going to look something like this. All right, Danny, you have to look at number 5 here, okay? Take a look at number 5. Make sure you write these 2 notes down here, Danny. All right, I don't want to see guesses for this one. No guesses. This is like a straight up memorize this rule and do it. So if it's positive, up. If it's negative, down. You take out the guessing. We just want to have at least some expectations here about what kind of graph that we're going to see once we put it all together. So smooth out them guessing wrinkles and make proper educated guesses. Yep. I want educated responses and guesses, not just like random guesses. Shot in the dark, you know. I felt bad when I did that. When I was learning math back in the day, I used to do that all the time. All right. Next, step 2. Let's do x and y intercepts, okay? So that's going to be our next thing here. Let's first do x-intercepts, because that's usually the toughest of them. So x-intercepts here is all we're going to do is set this y is equal to 0 and the solve for x, okay? So here we're going to have x squared plus 3x minus 10, and we're going to set that equal to 0. Okay. So here's a question. Does this, let's go ahead and try and solve for x here. The first thing we'll go ahead and try is, does this factor? Does x squared plus 3x minus 10, does that factor at all? Does that factor nicely or no? You guys tell me. Does this factor x squared plus 3x minus 10? All right, 5 and 2. 5 and minus 2. Okay. So x plus 5, x minus 2. Okay, very good. Very good. That's correct. All right, good pickup there. We have x plus 5 and x minus 2. Now again, if it doesn't factor nicely, if it's not so easy, remember, try your other methods. So go ahead and try the square root property if you can. Some obviously, most of them don't use that often, but some of them don't use it often. You could try the completing the square. You could try the again the quadratic formula. Again, quadratic formula would be your last resort, or again the AC method if you were dealing with tougher numbers. You try using the AC method and see if that works out. So AC method would be the first one, or like regular factoring, like simple factoring, and then AC method. You could try doing completing the square, or again, maybe an easier resort for you. Maybe the quadratic formula. Totally up to you. But again, try something on the easier spectrum first, and then if none of those work out, no matter how hard you tried, maybe you had to take a step back a bit. Let's try and find out. how that'll work. All right. In any case, you know what? I'm talking too much here. All right. What do we get for x here? What are our answers for x? What's x going to equal here? -5 and 2. Good. Let me point out something here. The common thing that this is where things have. I'm going to be honest with you. Like the first time I've asked you that question when it comes to factoring, you guys said 5 and a lot of you guys said 5 and -2. And now you guys actually, when you see it on the screen, you guys say -5 and 2. And that shows signs of really good progress. So like you can see like, oh, yeah, it's actually that opposite there. So taking away the assumptions and you see it on the piece of paper, you're like, oh, okay, that's what it is. So glad you guys did not skip steps there. Very, very, very good feeling to see. All right. So here we have two x-intercepts. We have -5, 0, and we also have 2, 0. That's going to be our two x-intercepts here for a certain. So here's what's the nice part is that you already have 2 points on this graph. Very simple. Okay. Let's go to the next part here. All right, so the next part here is probably just as easy. Probably it's easier, actually, I should say. Y-intercept. Y-intercept, remember, we just set x is equal to 0 and solve for y. This one here is just plopping in 0 into the function. Nothing too fancy about there. Basically, we're just going to take f of 0, and we'll just put in 0 in for x in here, which is 0 squared plus 3 times 0 minus 10. So here we get minus 10. All right, so nothing too great going on here. But we do have the y-intercept here at 0, comma, minus 10. So now we have 3 points on the graph. We have the two x-intercepts and the y-intercept. So we have a pretty solid understanding here, at least about some solid points on the graph here. We haven't found the most important point here yet of the vertex, but we're going to do that here in just a moment. Okay. Yes, of course, Blink. Go ahead. Is -10 in A? In a bracket? Oh, no, that's a parenthesis. Oh, that was your question. Yeah, this is not interval notation. I just kind of wrote that really bad. I ain't gonna lie to you. Yeah, this should just be a parenthesis. No, it's just such a point. So the definition of a y-intercept, Blink, is where it hits the y-axis. So if it's where it hits the y-axis, right? If it's any point in and along here, x has to be equal to 0. So that's just the rule for y-intercept. X has to be equal to 0. So what's the y value where x is equal to 0 for a y-intercept? That's why for x-intercepts we set y is equal to 0. Where is it? Where is it hitting the x-axis? What points here is it hitting the x-axis? So those are rules that you're going to have to kind of get to know. So give yourself a friendly reminder. Like if you ever get confused, write it out like I did here and says, okay, all right, what do I got to do for the x-intercept? Okay, I got to set y is equal to 0 and solve for x. Okay, that's what I'm doing. All right, as you get the y-intercept, it's like, okay, I'm just plugging in 0 for x and I'm just solving for y. And like that's what I'm doing. So I'm like, okay, that's fair. Any other questions before I move forward? Any other questions? Phone is blowing up. Shoot. All right. No. All right. All right. Let's go ahead and move forward here then. All right. So, moving forward here, let's go ahead and take a look here at the next one, next part. Okay, so the next part here is step number 3. Basically, I'm going to find the vertex of this quadratic function. All right, that's what we're going to do here next. Let's find that vertex. So to find the vertex here, I'm going to rewrite the equation here. Here we have, just rewrite the function that we're working with. X squared plus 3x minus 10. Okay, fine. So what's a and b here in this case? Because if we're going to do the x value of the vertex, right, we use the shortcut here. X is negative b over 2a. All right, fine. So what's a and what's b? Let's at least talk about that. What is a and what is b here in this particular equation? What is a and what is b? All right, good. So a is 1 and b is 3. All right. So let's plug in those numbers into our equation there. Oh yeah, okay. I had to look at that for a second, Brian. I'm like, oh, okay, I know what you meant. All right. So here we're just going to plug in the numbers here. We have negative 3 over 2 times 1. Okay. So here we're going to have negative 3 halves. All right. And that's what we're going to have here. All right. So that's going to be the x value of our vertex here is going to be negative 3 halves. Remember, give yourself a reminder here if you need to. This is only part of the answer, not the whole answer. So if you answer that on the homework there, you're like, oh, what's the vertex? And you just say negative 3 halves, that's wrong, okay? You already got the problem wrong because remember, the vertex is a point and not just a number. Okay. All right, so what we need to do is for y, we need to go ahead and plug in negative 3 halves into our function. So let's see what we get with that. So plugging that in, we get negative 3 halves squared plus 3 times negative 3 halves minus 10. Okay, exactly right, Brian. We're going to plug it in for x. Absolutely true. All right. Now, in this particular instance, let's take a look on how that will work out once we go ahead and put this together here. So let's take out our calculator for this one. I'll show you on the good old calculadora. I haven't used the calculator too much, but again, sometimes can be very helpful if I can show alternatives here. Okay, so we're gonna go ahead and plug this this guy in here. So, all right, it's over just a smidge. Okay, maybe that was more. Maybe I don't know what I'm doing about half the time of my life. All right, maybe that was already true from the get-go. All right, anyway, I digress. In any case, let's take a look here at how we can do this out. We're going to put negative 3 halves here, quantity squared, plus 3 times negative 3 halves. So again, just like so. You could just put it in just like so. Calculator will assume multiplication here. And then minus 10. And then if you want to get the fractional answer here, again, decimals will not fly here for the homework either. So hit the math key, go to number 1 here, which says fraction, hit enter. So this is what you should see here on your screen, and then hit enter again. And then there you go. You have yourself a winner at 49/4, negative 49/4 here. Now again, you can manually do this as well. That's perfectly fine, just to verify your results. So either way, doesn't matter. But you know, just making sure that we have our bases covered nonetheless. Okay. All right. So we have our x value here, and we have our y value here. So if we put this together here specifically, our vertex here is going to be specifically here. Let's -3/2, comma negative 49/4. Okay. So -3/2, comma negative 49/4 is what we have for our vertex. There any questions about that? All right, let's answer this simple question then next. All right, now we have the brain juices flowing here. All right, so we're on a good pace here. All right, so I like where we're at. Now we do the next step here. So it's like, okay, well, what's the next step? All right, the next thing that we're going to do here is we're going to go ahead. The next step here is to find the axis of symmetry. All right, because the questions here will find axis of symmetry. Anybody tell me here, what is the axis of symmetry? What is the axis of symmetry here? So I will go back to our notes here for axis of symmetry. What is our axis of symmetry going to be here? -3/2. What's equal to -3/2? X is equal to -3/2. Good. It's an imaginary line. That's the definition. I just want the equation for that line here. Equation for that line is x is equal to -3/2. So again, it will mark you wrong here on the, it may mark you wrong here for the homework if you don't put x is equal to -3/2. If you just put -3/2, it'll say, oh, that's not quite right. So again, just making sure we cover our bases there. Again, so it's always x is equal to the x value of the vertex. Yeah. Again, if you want to visualize what the axis symmetry is, just as a visual representation, this is what it actually is. It just cuts that parabola in half. It's just an imaginary line. That's all the axis symmetry is. So it's just like a big old cake cutter, cuts in half, bam, got it. Darn it, I said cake. Oh, cake does sound pretty good right now, actually. I, I, I would love some cake. I don't have too many sweets. I'm like, oh, cake sounds pretty decent. All right. Anyway. All right. Now that we have all that set and ready to go, let's go ahead and put it all on a graph. Put it all on a graph. We can take a few more optional points if you want. So the last step there is to find more points. That's completely optional. Technically, I guess I'll put that down here. This is optional if you want other points on the parabola. If you're not sure. This can apply because sometimes you may not find x-intercepts. That's entirely plausible. Okay, so it just depends. All right, but again, we just don't take it for granted necessarily. So If you want to find extra points, totally up to you. Why did I do that? All right. All right. Trying to get to here and all right. Okay. Well, let's go ahead and take a look here at the graph, looking at some of the points that we need to put together. So first and foremost here, we have our two, yes, that is correct. 100%. I agree with that. I agree with that assessment. AOS is playing Fruit Ninja. Absolutely, 100%. Totally agree with this. Only it's just a straight cut down the middle. It's got that super laser cut. Not one of those off cut things. It's a super laser cut, like precision based. It's like you have a bot playing Fruit Ninja for you. Just saying. All right, so we have -5, 0, and 2, 0 as 2 points. So you're probably saying, well, so many Looney Tunes. All right. We have two x-intercepts here, -5, 0, and 2, 0. That part is true. We also have a y-intercept here at 0, -10. So we're going to put that down. It's a pretty good analogy. I ain't going to lie. It's a good analogy. All right, so we have a y-intercept here at 0, -10. We have two x-intercepts here. And we also have the vertex here. Now, the vertex here specifically is at -3/2, comma, -49/4. So -3/2 is like -1.5. -49/4 is -12.25. All right. So if you're trying to get like -12.25, then you just kind of because if you're trying to eyeball it, that's what you're essentially going to do. Obviously, on the computer for the online homework, it'll be more precise. But I'm just drawing it on a piece of paper, so I'm just going to have to eyeball it a little bit. So this is space. So, I didn't mean put that. So that is right about here-ish. Right about here-ish is where that vertex is located. And so we can go ahead and draw this parabola out. Okay, so there's my vertex there at the bottom. Again, I know it's not perfect, but hey, it's a thing. So, and there is our vertex. Yay, with terrible arrows. Art is not my thing. All right. Okay, so there is the parabola here for this particular problem. Okay. Actually, that example took longer than I thought, so I may have to forego the second example here. But are there any questions about that? Are we going to be able to type the vertex in on the homework and it'll automatically graph? Yeah, you should be able to actually. I think so. I think you should be able to. You can eyeballing it is going to be tough with fractions. I ain't gonna lie, but I think you should be able to type in your vertex there. So if not, then yeah, you can try and eyeball it. There's like a little thing on the upper right hand corner that shows you the coordinates and stuff. No, Brian, I agree with you, buddy. Brian, I am not disagreeing with you. It's gonna be hard AF, man. I ain't gonna lie. Math is already hard AF. I'm adding more complex layers to make your life miserable, bro. Okay? That's just how it is. Every single class, okay? My dude. That's every every class with you, Brian, is like delving more and more into the world of despair. I know for a fact I'll never satisfy you, but at the very least, we're just gonna try and make it as palatable as possible. Darn right. Definitely gonna rewatch today's session. No problem, Danny. Absolutely. That's why the replays are there if you need to rewatch it several times. I had a few people like they watch the replays like a few times for every single question. That's fine. If it helps you understand it, that's fine. But that's why I'm here. You can ask me questions too. I ain't going anywhere. That's not how it rolls. Okay. Gotta love the pessimism, man. Pessimism in a math class? I've never heard of that before. Oh my gosh. I thought that was a myth. I was mistaken. Hey, what's that on your face? It's naivete. Yes, it is. All right. All right. All right. Any other questions here about section 3.1? Sorry, my bad. Which part there, E-Man? You want me to just expand on the notes here? Step 4. So step 4 is basically the axis of symmetry part there. So the axis of symmetry is always going to be the x value of the vertex there, E-Man. So here we have -3/2 because that's the x value of the vertex. So x is equal to -3/2. Again, the axis of symmetry is just like this imaginary line that cuts that parabola in half. Then what I went ahead and did in the next step was to make the graph here. I took all the points that I had here. So I took each one of these 3 points here. So I took these two points for my x-intercepts, these 2 points for my y-intercepts, right? And then I had found my vertex here in step 3, and then I went ahead and actually put that on a graph. Again, this is a hand-drawn graph, so it's not going to be super exact. But as I said here from the homework, you're going to have like a little bit more precision than that. So it'll do more than I can. So I bow down to technology. All right, it makes me the better hermit that I already am. All right, I am the best hermit. Okay, don't you forget it. All right, I'm just saying. Being a hermit feels good, Okay, on occasion I go outside. On occasion, just saying. All right, and the eyes kind of sting, just a little bit. Me and my, one 1/16% of the vampire blood. I'm just saying. So. All right. So next, let's talk about the next part here. All right. So the next one here, I'm gonna kind of shorten this a little bit here, but let's take a good look here at section 3.2. There's some basics here that I want to talk about here when it comes to section 3.2. And then next time here, we're going to expand upon that here just a little bit. So let's talk about some of the concepts in here because this is going to be the introduction of a lot of what we're going to be doing here in this chapter is going to revolve around these first few questions. So quadratic functions here are a very specific type of function that has its own kind of properties and things that we deal with. Now, we're going to go even more general than that. We're going to be looking at polynomial functions. So let's take a look at question 1 here. Question 1 says, what is a polynomial function? Well, it's a function of the form, and then this is the super general form that you see here on the screen. You're like, an x to the n, an minus 1 x to the n minus 1. plus a1x plus a0. You're like, all those a values here can be whatever number you want them to be positive, negative numbers. But the more important part here about polynomial functions that has to be true is that n here has to be a non-negative integer, okay? So n here has to be a non-negative integer. So it cannot be a negative power, okay? It cannot be a fractional power, all right? It has to be a non-negative integer. So that's why I put here specifically 0 and above, okay? That is how we want the powers for the x's to always work out to be. Okay, so we can have any numbers there for the a values, but the powers for x's are the most important part to define our polynomial. Those absolutely have to be 0 and above, and they have to be like integers, okay? They have to be 0, 1, 2, 3, and so on. All right, so nothing in between. I'm not allowed to have that at all. All right, so an example of a polynomial here would be negative 4x to the fifth plus 10x to the fourth plus 30x to the third minus 10x squared minus 40x plus 100. Okay, so I just made it up with some random numbers. Here's an example here of a polynomial. It's pretty straightforward, at least in that regard. Okay, well, let's take a look here at some of the other examples. This is a simple yes or no question to see if these are polynomials. So I'm going to write these down here. And you guys just simply tell me it is a polynomial or it is not a polynomial. Nothing too great going on here, but something fairly straightforward. So let's start off with this. Polynomial, yes or no? Is this a polynomial, yes or no? Okay, fine. The answer is yes. It is definitely a polynomial. Okay, we got x values. Again, the powers for those x values are going to be non-negative integers. That's perfectly fine. Look at another one. Is this a polynomial, yes or no? Is this a polynomial, yes or no? I'm gonna put this one to a poll. Actually, this one is actually poll worthy. I see. I have a sense that people have it on two sides. So let's do something a little bit fun here. So put it up for a minute. So we got the poll at the top of the chat there. You can go ahead and click on that. Polynomial, yes or no? That's actually really interesting. We have about 20 seconds left before the poll closes. We got 7 people say yes, 5 people say no. Okay. 8 yeses, 5 no's. All right, and we're out of time. All right, so we have 8 people say yes and 5 people say no. All right, so let's talk about the answer here. What is the answer to this particular problem here? The answer to this particular problem is going to be answer is no. The answer here is no, is actually the minority actually guessed correctly over the majority. Now, the question is, why is this a no? There's a -3. That doesn't matter. Any number in front of the x's they can be any number you want. They can be positive or negative numbers. That's perfectly fine. All right. That's correct, Stephen. The answer to this is actually this last term right here. One of the things about 1 over x is that can be rewritten. That can be rewritten as x to the minus 1. It's one of those properties of exponents. One of those properties of exponents that we if you remember kind of way back in the day, this is that property of exponents that you can change that from a positive exponent to a negative exponent if you move it from, say, the denominator to the numerator, or again, moving it from numerator to denominator, you flip the sign of the exponent. So, in fact, we actually have x to the minus 1 here as a result. Well, too bad, so sad. We are not allowed to have negative integers as our powers of x. So that is why in this case here, the answer is no. So that would violate our definition that we had there to begin with. All right. Stephen, did you guess? Did you guess yes? If you guess yes, that's fine. So that's why that's why this problem here was like a divisive one. This was like a divisive problem. Fair. Fair, that's a tough one. That's why I asked that one. Brain fart, hey, we all been there. Everybody been have a brain fart. How about this one? Yes or no? X to the 1/2 plus 3x squared minus 2. All right, people talking about. We decide if it's yes or no depending on positive. Yes. So again, it has to be a non-negative integer. Okay. So the exponent here for x has to be a non-negative integer. It cannot be negative, and it can't be a fraction or a decimal. Not allowed to have that happen. To answer your question there, Brian. Oh. Nope, it can't be a fraction. Nope. As you can see here in this problem. That's why I put that one down. Okay, so the answer is no. X to the 1/2 does not count. That does not qualify as a polynomial. That's a definite no-go. One more. How about this one? Yes or no? Yeah, I agree with everybody here. Yep. 100%. Absolutely 100%. Yep. If there was an x on the denominator, then the answer would have been no. So if I had like 4x on the bottom, then the answer is no. But if I have this, the answer is yes. All right, very good, very good. All right, so that's again, I just want to go over the basics here about. So if you had this, right? Here's the problem with 4x on the bottom. The answer to this is no. So the reason why, Blink, that this would be a no is because you can rewrite this x again. You can bring that up to the top here. Another way to write this is x to the minus 1, x squared minus 3x over 4. This is a no-go territory. Yeah, if I put even x to the 4th, this would be a no-go territory. So because you can make that negative, that's why it's not a polynomial. Unless you simplify it down where you can, but in this case it would not be. It would be like x to the minus 4, for example. Then you'd be like sadness. You distribute, you get the same thing. Get a negative exponent. That's bad. You don't want that. No, I take that. I take part of that back there, Blink. I take part of that back. This would work technically. Like I think this would work because you can simplify this down. I'm gonna take part of what I said back. Part of it, but it's a detail here that's super subtle that I'm never gonna test you over. So technically this would be like x minus 3 if you actually divided this out. But this would be a polynomial, that would be fine. But if you had, say, like a power of x to the minus 4, for example, yeah, then this is going to end up to be like, if you simplify this, would be x to the minus 2 minus 3x to the minus 3. And then by that point, you're already done for. So the answer to this would be yes, because it simplifies into something. Because you can cancel stuff out. This one here, it's not going to work out in your favor. Again, this is a really small, subtle thing. I'm not going to like test you on something like this because it's not like I really want to make a big stickler on this particular point. All right. I just want to make it a little bit more clear about other things. But yeah, you asked the question, so to be fair, full transparency, I'll answer it that way. But I'm not going to test you on that because that's way too much minutia. That's just too detailed. That gets to be a pain in the ass, and I'm like, yeah. There's a line that I follow, a line that is followed very carefully. See, I'll be honest with you. A question sometimes when you get too much into the details, that's when things get overwhelming for everyone. That's that line that you basically say, yeah, that's I'm not crossing that point, and I'm not gonna make you cross it with me. I know it, but yeah, don't worry about it. Yes, that's true. Onions and algebra certainly have layers, Danny. They're also like the awesome blossom at Outback Steakhouse. Fried and mediocre. I'm just gonna point it out there. You could have a little bit of dipping sauce, but it doesn't save the entire dish. And then you feel like, you know what? That was a $6 that I spent on something that was kind of like, eh. I hate that feeling. That's like the worst feeling. When you spend that amount of money on something and it's kind of meh. You had higher expectations for the amount of money that you're spending. All right. Let's take a good look here. All right. Let's take a good look here at number 2. All right, we're going to look at a few more things here. Number 2. Number 2 says, what is the degree of a polynomial? So one thing we're going to talk about in this section and other sections here is talking about using the idea of the degree of a polynomial. The degree of a polynomial is the highest power or combined power in any single term in the polynomial. Okay. So let's point out a couple of examples here right away about degree, and you guys can fill in the blanks. Let's say so. Can anybody tell me here what is the degree of this polynomial? So this is a polynomial here, and what is the degree of this polynomial here? It's just a number. So the largest power we see is 5. That is correct. Okay, good. Right? So we look at every term, we find out what's the highest power we get, and that's in this case is 5. And then it's like, okay, fine. 5 is the correct answer. Easy enough. I totally agree with this. Let's look at another one. All right. I'll put it one more. Yeah, just for giggles. All right. What's the degree for this? That's a good guess. That's a good guess is 4, but actually 4 is not the right answer. Though that's a very good guess there. This is the other part of the definition here that I will highlight, the combined power here in any single term. So if you combine the powers here, that will tell you the degree here. So if you have two variables here, that's why I say 4 is a reasonable guess, but then you're looking at combined here in a single term, and the answer is indeed 6. Right. The answer is 6. So again, this would be 2, this would be 4 because that's 3 plus 1. This is 6 because we have 2 plus 4. We got 3 plus 2, this is 5, and then this is 1. So you can see exactly how this works out. We're combining the powers here together. In this case here is a degree 6. So what we're going to be looking at here, and specifically for polynomials, is we're going to be looking at properties here that is associated with degree, because there's actually very important properties associated with the degree of a particular polynomial. This helps us predict the behavior of the graph of a polynomial, looking at the degree and looking at a couple of other things as well. Within the polynomial. So we're going to be at least exploiting this idea here in conjunction with a couple other things to look at graph behavior here. That's what we're primarily going to be doing here in this section and in possibly other sections as well. Maybe not so much as graph behavior, but things that we can find within the polynomial, and we can use the degree to help ourselves out with that. Okay. Now, here's where I'm going to stop here for today is number 3. I'm going to do number 3, and then we're going to start off at number 4 here for next time. So number 3 says, what is the leading coefficient of a polynomial function? And this is pretty simple here. So again, that's the number that's in front of the highest degree term in the polynomial. All right, simple enough. It says leading coefficient. So note the difference here. Leading coefficient is not the first number you see. It is the number in front of the biggest degree. That is what you want to look at. So if I look at this this example here, what's your leading coefficient for this guy, for the first one that we had here with degree 5? What's the leading coefficient for that? What's the number in front of the highest degree? So if the degree is 5, we have x to the 5th, right? What number's in front of x to the 5th? It's minus 5. So this is going to be our leading coefficient. That's the number in front of x to the 5th, which is our definition of our degree here in this case. What's our leading coefficient here in this instance for this second one? Okay, good. What's our leading coefficient here for this second example? 6. Okay, good, right? It's this 6 that's right here. Now again, most of these functions here, admittingly, for polynomials will be written in order, but if they are written out of order, at least you know exactly where to find these leading coefficients. So I'm not like promoting rocket science here. What I am saying is that, hey, you want to know what this leading coefficient is going to be? Okay, it's right in front of your largest degree term. That's that particular number, and then that's what you're going to roll with. So I want you to keep that in mind here for tomorrow, as we are going to start here with number 4. Again, there's a reason why I'm not going to start with number 4, because that the next few questions here pretty much kind of go together here as part of our step-by-step process. So I don't want to do one step and then stop, so that doesn't make any sense. All right. Any questions for today, ladies and gentlemen? Any questions for today? I'm going to stop off here a bit early here today, but I think we ended off here on a pretty good part, so we're in good shape. All right. Okay. Very good. All right. Let's go to the big board here. Noel, indeed. Hello, Golmesh. All right, ladies and gentlemen, thank you so much here for coming on out here to the stream today. All of you, thank you so much for participating. Thank you so much for the very nice words. That's very good participation here. But there you go. Thank you, Joseph, for the hydration. All right, non-lesson, but a number on the homework. Fair enough, Jess. Thank you for the hydration. Thank you. All right. All right, and I will see you all here tomorrow. Same time, same place, right here on Twitch, ladies and gentlemen. Thank you so very much. And as always here, stay safe, stay healthy, but most importantly, stay sane. Have yourself a wonderful day, everybody. Take care of yourselves, everybody. Jess, we'll talk on Discord here. If you guys want to talk, we'll go ahead and talk on Discord here. I'll be more than happy to answer any questions that you may have. All right? Have yourself a great day, everybody. We'll see you later. All right. Have a great one, everybody. Take care of yourselves. All right. Bye.